Hello, my name is Fakih. Today I'm going to presenting a final project that I will propose entitled Implementation of Partial Time Sequence Method as PAPR Reduction and Linearization Techniques in OFDM system using Universal Readable Software with LabVIEW and Python. For this final project, I'm being advised by Mr. Yudi Milgarto as first advisor and Mr. Ahmad Zainuddin as second advisor. OFDM is high-speed multi-carrier modulation technique in wireless communication. It uses several frequencies that are perpendicular to each other or orthogonal. It has several advantages: suitable to save bandwidth, remove inter-segment interference, high-speed data transmit, and many more. For the advantage of OFDM, high PAPR result in nonlinearity in power amplifier. Nonlinearity causes the subcarrier to be no longer orthogonal and may degrade the performance of OFDM system. The purpose of this final project research are: first, implementing partial transmit sequence as a technique to reducing PAPR on orthogonal frequency division multiplexing using USLP. Second, implementing linearization technique to reducing distortion and increase power efficiency. The last, analyzing system performance using PAPR and CCDF graphs. In OFDM theory, the binary data enters serial parallel block to convert from serial input to become parallel output. Next, data enter modulation block so it can be modulated with the modulation that already been chosen. For this final project, I choose KAM. Then data continue to EFFT block. It convert from time domain to frequency domain. Next, the data add with CP or sector prefix to prevent intersymbol interference. Next, the data enter parallel to serial block to convert back to serial output before transmitted to receiver. In the receiver, the data enter serial parallel block to convert back to parallel output. The CP are removed. Next, the frequency domain converted back to time domain with FFT. Then the data continue to demodulation to remove the KAM. Next, the data enter parallel to serial block to convert back to serial output. Peak to average power ratio, or PAPR, is a comparison between the maximum power of a game signal and the average signal power. High PAPR can cause nonlinear distortion, which result in intermodulation and spectral leakage. Amplifiers with wide dynamic range are needed to reach these high PAPR values. These are PAPR equations that can be used to calculate the value of PAPR. VTS theory starts with input binary sequence enter modulator. For this fan project, I use KAM. Next, the output enter serial to parallel block. It converts from serial input become parallel output. Next, the data enter multiplier alongside with phase optimization. Next, FFT convert the data from time domain to frequency domain. And the last, the PAPR with the lowest value are being chosen to transmitted alongside with set information. All this figure illustrates the PA or power amplifier transfer function graph that shows the correlation of input to PA output. Based on the picture, PA is said to be ideal if it is in linear region. PA will then experience saturation as the input power increases. For the signals with large PAPR values, the operating point must shift to the left or to the linear region to maintain linear gain. These are methodology that I'm gonna use to plan my research. Start from planning a frame system, simulation with LabVIEW and Python, testing the method and technique, up to analyze the data. This is the system design. The concept is to connect PC or laptop to an USB with RJ45 cable so it can transfer the data into the receiver. Basically, it has same structure but different function. In transmitter, it has program to transmit the data, but in the receiver, besides it used to receive, also used to transmit the data. This is block diagram that proposed by me for this final project. It consists of original OFDM scheme and partial transmit sequence scheme. For the linearization technique are included in the LabVIEW program and later as physically attached to scheme in form of high power amplifier. it located in transmitter module it used before the data are being transmitted. The expected result for this project is, first, linear system output are stable, PAPR prediction become much lower as expected, PAPR are lower than other techniques, CCDF measurement are lower than the other techniques. I think that's all for me. Thank you for attention. See you again.